These are the notes for measures of central tendency. So the measures of central tendency describes the center of a set of data. There are three terms for measures of central tendency, and that is the mean, the median, and the mode. The mean is simply the average of a set of numbers. So the way we find an average is we add all of the numbers up, and then we would divide by the number of numbers that we have. The median is the middle number. So what's really important with the median is that we put the numbers in order from least to greatest. That's a really important step. If you don't do that, you will not get the correct answer, most likely. Two scenarios can happen here. If we have an odd set of numbers, it's very easy to tell the median because it's the number in the middle. So that's all you do. You pick the middle number and you have the median. If you have an even set of numbers, you have to work a little harder because there is no distinct middle. So just think if you had 6 numbers, you would have 3 numbers right away, and then you'd have 3 other numbers. So there's nothing in the middle. So what you would do is you would find the mean, or the average, of the 2 middle numbers. And when you do that, that would give you your median. The last measure of central tendency is called the mode, and this is the number that appears the most. The way I like to think about that is mode has an O in it, and most has an O in it. You can have one mode, you can have more than one mode, or you don't have to have a mode at all. If every number appears just once, there would not be a mode. Another vocab word that's not a measure of central tendency but still important is called the range. And the range is just the difference between the max and the min value. So difference, remember, is subtraction. So you take your biggest value, you subtract your smallest value, and that gives you what's called the range. Example 1 here. It says the weights in pounds of 5 cats are 12, 14, 12, 16, and 16. Determine the mean, the median, the mode, and the range of the data set. So I will start with our mean first. So remember, for the mean, you're adding all of the numbers up. So we are going to do 12 plus 14 plus 12. And when we add all of those up, we get 70. And then you divide by how many numbers you have. So in this case, we have 5 different numbers that we're working with. So we're dividing by 5. And we get our mean of 14. So the average is 14. Okay, for the median, really important that we put the numbers in order from least to greatest. If you have a number that's repeated, you do in fact want to rewrite that twice or 3 times or however many times you have it. So there's the numbers order from least to greatest. Notice we have an odd number of numbers here, right? We have 5 numbers. So the median's pretty easy. It should stick out at you, and the median there is 14. Next, we have our mode. That is the number that appears the most often. So here, notice we have 12 appearing twice, 14 appearing once, and 16 appearing twice. So we have a tie for the number appearing the most, which is 12 and 16. So here we have 2 modes, which is 12 and 16. Lastly, we have our range. So that is our biggest number minus our smallest number. So that would be a 16 minus a 12, and we get our range of 4. Okay, the next example. The weights in pounds of 6 members of a basketball team are 161, 156, 150, 156, 150, and 163. And we have to find those 4 things again. So again, I will start with the mean, and we want to start by adding them up. And when we do that, I got 936. And then, of course, we want to divide by how many we have. And here we have 6. And we get 156. If you would happen to get a decimal, that is okay. You would want to record that decimal. That matters. Okay, for the median, again, we're putting them in order from least to greatest. Okay, and I believe I did that there. Now, because I have an even set of data here, I have 6 numbers, I have to find the mean of the 2 middle numbers. So the 2 middle numbers I am highlighting now in yellow. So I need to find the mean of those. So I would do 156 plus 156. And then divide that by 2. So when I do that, because of the same number, I just arrive back at 156, of course, which is okay. That is my median. Okay, our mode is the number that appears the most often. So it looks like we have a tie again here with our data. It looks like 150 and 156 both appear twice. So they would both be our mode. And lastly, we have our range. So we're going to take our biggest number, which is 163, and subtract our smallest number for a range of 13. Okay, example number 3. Andy has grades of 84, 65, and 76 on 3 math tests. What grade must he obtain on the next test in order to have an average of exactly 80 for the 4 tests? So a little different here, where we have 3 data points, we have 3 test grades, and we want to know what we need to score on the next test in order to have an average of an 80. So we know the average we want here. So because it's looking for a mean or an average, we're still going to use the same formula, where we're going to take our test scores, 84, 65, 76, and we need our 4th test. So we're going to add our 4th test here, which we don't know what it is. We're going to call that X. And we know that when we find the average of these 4, so we're dividing by 4 of them, we want that average to equal 80. And that's the formula we're going to use here. So now we're solving for X. We want to get this out of a fraction first. So since we're dividing by 4, we're simply going to multiply by 4. And in the numerator, I'm just going to add those 3 together. In the numerator, I get 225 plus X equals my 80 times my 4, which is 320. And now very easily we can subtract 225 on both sides. And we see that our average needs to be a 95. And that would be my answer. Okay, another vocab word here, outliers. Outliers are values in a data set that are much greater than or much less than most of the other values in the data set. So they don't fit in with the rest of the points. And this can affect the mean, the median, the mode, and the range. So you can see here in our little number line, most of your data is on the left-hand side here. And then we have an outlier, something very different. What that does is that makes the mean, in this case, the average, greater than what the class is showing here. So if we're saying this is test scores, for example, let's say most of the class got around a 70, and then we have someone up here that got a 98. Well, according to using all this data, maybe this mean would be like a 76. So as a teacher, when I'm looking at this, if I see the mean of a 76, I might think, maybe that's okay or low or high or, depending what it is. But in reality, I should really take this outlier away when I'm doing this mean to get a more accurate representation. So if I got rid of this 98, just in my calculations, this mean would then drop down towards that 70 more. And that would give me a better representation of how the class did on a test. This can obviously work in the other direction as well, that if the class, if everyone got a 90 or a lot of people got a 90 and then someone got a 20 on the test, it would bring the mean down pretty low, and that would not be an accurate representation either. So that's what an outlier is. So example 4, you are competing in an air hockey tournament. The winning scores for the first 10 games are the following numbers there. And it wants us to find the mean, median, mode, and range of the data set. So we can do that. We need to add everything together. So I have my calculator here. You want to be very careful when you're doing this. I would do it 2 or 3 times, add it in the calculator so you don't miss a number or mistype anything. When I added them, I got 140. I'm dividing by the number of numbers we have, which is 10, and I got a mean of 14. For the median, we are arranging everything in order from least to greatest. Again, be careful here when you list your numbers. Maybe you do what I'm doing, and as you're writing them, you're crossing them off the top of the list so you don't forget any. So 12, 13, 13, 14. It looks like I have 4 15s and a 17. So I'm going to recount my data points to make sure I use 10 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I did. So since I have an even set of data points here, I know I'm going to have to work a little bit harder. I'm going to have to find the mean of the 2 middle numbers. So I'm going to have to find the mean of 14 and 15. And when I average those, I get my true median of 14.5. Okay, my mode, 15 is definitely my mode, right? Because that's appearing 4 times. So there's no tie there. The mode is 15. And the range, I would do my biggest number minus my smallest number, and I get a 6 for a range. Part B says the winning score in the next game is an outlier of 3. Find the new mean, median, mode, and range. So let's see how that outlier affects this. Since it's such a low outlier, right, it's below most of the data, I would assume that this brings down the mean and the median. So let's see what happens to the mean. So instead of 140 now total like we had in part A, I'm adding 3 to that. And now instead of dividing by 10, I'm dividing by 11 because I had another data point. And when I do that, I got 13. Mode-wise, I'll do median after. Mode-wise, I didn't change anything with the mode. 15 is still my mode. Median, I'm adding that 3 to the beginning of my data set and then just rewriting the points in order from least to greatest. And now since I have an odd set of data, I only have 1 middle point there. So my median is now a 14, when before it was 14.5. So it did lower that, and it lowered the mean too, from 14 to 13. And then range, 17 minus my new number of 3. My range went up quite a bit. And remember what the range tells you, it's just how widely your data is dispersed. So if we add a super low or super high number, it is going to be dispersed over a wider range. And lastly, part C says, which measure of central tendency does the outlier affect the most? Well, the most that it affected was the range. And the least, let's see, the mode did not change at all, right? So the mode it would have affected the least.